This is CPM Precalculus Chapter 3, number 79. So the graphs of f of x and g of x are shown. Okay. Then we're asked to give an expression in terms of f of x that will transform the graph into g of x. So what that is saying is we start here at f of x and we finally get to g of x. What transformations took place to get there? Right? And we know many types of transformations, okay? So let's start off by listing the types of transformations that there are. Okay? So we know there are stretches or shrinks or compressions is one type. We have vertical stretch or shrink or compress, right? Remember that's up and down, vertical. And we have horizontal stretch and shrink or compressions, and that is from left to right. Okay? We also have reflections across the x-axis, right? We have reflections across the x-axis, and we have reflections across the y-axis. Alright, and remember the x-axis is the one going like this, so we are reflecting across. The y-axis is the vertical one, and we are reflecting across that. Okay? Alright, finally we have shifts, right? We shift up, we shift down, we shift left or right. So that's vertical shift and horizontal shift. Okay, again, this is vertical and this is horizontal. And if we look at our transformations in this order from top to bottom, looking at our graph, we can go ahead and determine which ones take place and name them. Okay, so let's go ahead and do that. So let's go ahead and start with vertical stretches. And again, I ordered them specifically in this order. So you might want to take a note and think about why this order is important. Okay, so vertical stretches, what I'm going to do is I'm going to look at one region. So let's look at this partial parabola right here. And I'm going to look at the vertical height of it, right? The vertical height is the distance between here and this point and this point, right? These two lines. And this one goes from, here it goes 1, 2, 3, 4 units in height. And I'm going to look at the same height here. I know it's upside down because there's obviously some reflection going on. But the vertical height, again, I'm going to ignore everything else, but the vertical height is, again, 1, 2, 3, 4 units. Since these are the same, that's telling me that there's probably no stretch or shrink going on vertically. Okay? So I can go ahead and write now that none of this is probably happening. So I'm going to cross that out from the options of the transformations from f of x to g of x. Okay? So now let's move on to horizontal stretches and shrinks. Remember, this is going from left to right, horizontal. So I'm going to look at that same region, that parabola region, but this time I'm going to look horizontally, going from this point to this point, right? So we looking at the same partial parabola, and you could pick any region of the graph you want, and I'm going to count horizontally how the distance between these 2 points on the graph. So here I'm going 1, 2, 3, 4. Okay, this is 4 units, and from here to here, this is 1, 2, 3, 4 units as well. So this is 4 and 4. So that's going to tell me that there's probably no horizontal stretching or shrinking because these are the same in width, right? The width, the horizontal distance is equivalent. So I'm going to cross that out. And I know there's definitely transformations going on because these are not the same. But you want to go ahead and look at stretching or shrinking first. Okay. Next, let's go ahead and check for any reflections across the x-axis. We could do the y-axis first, but we just want to do reflections next. So, is there reflection across the x-axis? So remember, this is the x-axis. has there been a reflection across the x-axis? Okay, so I'm going, like right now I see that there's a parabola shaped going down, and this one has the same thing but going up, right? So that tells me right away, right? And then I have this and the ray going up, and I have this parabola going up and the ray going down. So that's going to tell me right away that yes, there is a reflection across the x-axis, right? So I'm going to put a check and know that yes, this is happening. So I'm going to put a star here because yes, there's a reflection across the x-axis. Next, I want to see there can be both reflections across the x and y-axis. So is there one across the y-axis as well? So let's go ahead and look here at our graph. Here's the y-axis. Is there a reflection going on here? Meaning, was there a mirror right here and something's happening in terms of the y-axis? Okay, so I know that we already talked about there's one across the x-axis, but is there one across the y-axis? If so, this would kind of be the shape like this, right? We would see that this ray would be extended on this side of the coordinates, and this parabola would be on this side. And no, this is not the case because we have the parabola still on the left and the ray going up on the right. Okay, so I'm going to cross this out because this is not happening. So finally, let's go ahead and ask ourselves, any shifting going on? And yes, there is, but let's go ahead and see exactly how much. So vertical shifts. So let's look at, I don't know, let's look at this point right here, okay? Because that's equivalent to this point on this graph. Let's look at it only in the vertical direction. So this one is up here at the height of 2, right? It's the height of 2, and this one's the height of -1. So to get to the height of 2, it had to have traveled up 1, 2, 3 units. So is there a vertical shift happening? Well, yes, but is it 3 units? No. Okay, so we have to be careful to apply the transformations before it that have happened. So let's go ahead and do that, okay? So let's go ahead and quickly draw a sketch of if we took f of x and did a reflection across the x-axis, right? If we took the x-axis here and drew the reflection, we're going to go ahead and swap all of these points. So this one's going to go down there, right? This ray is now going down. Let me see if I can draw it well. You might want to use a ruler, right? And this parabola, this point stays here on the mirror, right? Is going to be, and this point, this vertex here is at -3, and it's going to look something like this. Right? Yep. Okay, and this point's the same. So I'm just drawing the reflection right now across the x-axis. Okay? Okay, so that right there is a sketch of the reflection. And if f of x is our original graph, well, reflecting across the x-axis, remember, is negative f of x, right? So that's in green here. So when we compare now vertical shifting, we have to look at what's in green. Because yes, what was in black here as f of x shifted up 3 units, but in green, we're going from the y value of 1 at this point to a y value of 2 at this point. So the y value is only going up 1 unit. So is there any vertical shifting? Yes. And it's +1 unit, right? It's not +3. You have to be careful to apply the shifts first, okay? So, excuse me, apply the transformations, the reflections, and the stretches first. So finally, is there any horizontal shifting? Since we only looked at the vertical shifting here, we can go ahead and look at the horizontal one without graphing this shifted up, okay? Because it's just looking horizontally. So this point here, horizontally, is at the x value of 1 here, right? This is x value of 1. Well, this point here is the x value of 4, okay? I'm looking at the graph in green. So in green, we're going from 1 to 4 horizontally. So that's going to shift to the right 1, 2, 3 units. Okay? So shifting to the right horizontally, remember, means we're going to go ahead. We can say it in different ways. This is going to be to the right 3 units, which is, we know, in parentheses, x minus 3, right? Because to the right, we have to have in parentheses the minus. All right? So that's going to go ahead and explain for us how to answer this question. Because what transformations took place? Well, let's go ahead and label them. Reflection across the x-axis we know is negative f of x. Vertical shift up plus 1 means we're going to go ahead and take negative f of x and add 1 outside, right? Horizontal shift plus 3, right 3, right? This is saying right 3 units, means inside we have to put a negative. So it's f of, and then inside the parentheses, x minus 3 plus 1. All right? So this right here is the final transformation of graph g of x. So this is equal to g of x, right? G of x right here is equivalent to transforming f of x by reflecting it across the x-axis, vertically shifting it up 1 unit, and horizontally shifting it to the right 3 units. Okay, and this is our representation, and we have finished. So that ends for us CPM Precalculus Chapter 3, number 79.